In this video, you're going to learn ArgoCD. By the end of this video, you're going to have a good understanding of what ArgoCD is, why we use it, and how we can use it to automatically deploy to our Kubernetes clusters. This video contains both theory and a walkthrough tutorial lab that you can follow along with that shows you how to install ArgoCD and how to deploy applications using both the ArgoCD web interface and command line interface. So let's get started. What exactly is ArgoCD? Well, ArgoCD is a declarative, GitOps-based continuous delivery tool for Kubernetes. It helps us deploy and manage applications on Kubernetes clusters in an automated, reliable, and repeatable way. It does this by continuously monitoring the current live state of applications in a cluster and compares it against the desired state defined in a Git repository. This is commonly referred to as making Git your source of truth for your configurations. Whenever a developer pushes changes to a Git repository, ArgoCD will detect the changes and sync them to the Kubernetes cluster. Syncing can either be a manual or automatic process depending on how you configure it. It can be a pretty common pattern to just automatically sync changes from dev and test environments, but have your production applications require someone manually syncing. So that's really the big picture of what you need to know for ArgoCD at a high level. You define your settings in a Git repository, and ArgoCD makes sure your environments reflect what's in Git. Let's now look at an example real-world pipeline that should give you a better understanding of the complete flow. So when it comes to GitOps, it's a best practice to have two repositories, one for your application source code and another one for your configuration code. In your configuration repository, you should have your Kubernetes manifests, Helm charts, or Kustomize files which would define your Kubernetes assets, such as deployments, services, and configuration maps. Whenever this configuration repo gets updated, that's when ArgoCD is going to kick in and do its sync. But that's not all there is to this story. Let's remember that ArgoCD is a continuous delivery tool. We still require a pipeline for continuous integration that will test and build our application. When a developer updates the application source code, that's when the code is going to be tested and the image will be built and pushed to a container repository. Your CI pipeline then could trigger updates to your configuration repository, which would cause ArgoCD to sync. This is a good example pipeline that many companies use when implementing GitOps into their workflow. Now, before we jump into the labs that are really going to cement your knowledge of how to use ArgoCD, there's two more things that you need to understand about ArgoCD, and that's its ability to enable disaster recovery, as well as its ability to orchestrate deployments to multiple Kubernetes clusters. You see, in the DevOps world, we don't tend to back things up anymore. We recreate them instead. With ArgoCD, if you were to lose a Kubernetes cluster, you could just bootstrap a new cluster and point your Argo deployment to your Git repository. Since everything is defined in code, ArgoCD would bring up the new cluster to the desired state and you're back in business. One more thing to mention is that ArgoCD is also not bound to a single Kubernetes cluster. You could have ArgoCD installed on one cluster, controlling the configuration of multiple clusters. If any of these clusters were to fail, it should be a trivial task to bring them back. If you were to lose the cluster where Argo is installed, it would also be recoverable as the configuration of Argo can be stored as a YAML file. So that's all the working knowledge you need to have to get started with ArgoCD. In the description of this video, I have provided a link to my GitHub repository which contains both a Helm and Kustomize application which we will be deploying to ArgoCD. If you're going to follow along with the lab, make sure to fork this repository so you can make updates that will trigger ArgoCD to sync on your changes. Other than that, all you need is access to a Kubernetes environment where you can install ArgoCD. I'm using Minikube, which you can download and get started with for free. We're going to be using both the ArgoCD web interface and CLI to deploy, sync, and troubleshoot the applications, so let's go ahead and get started. Alright, so I got a new Minikube cluster set up here, and the first thing I want to do to get started with ArgoCD is create a namespace, and this namespace is going to be where our ArgoCD is installed into. So I'm going to do a kubectl create namespace ArgoCD. And the next command I'm going to do is another kubectl command, and it's just going to be applying the ArgoCD manifest installation file. So these commands are actually in my GitHub repository in the description below. So if you're following along, make sure to grab those commands. And just to have a quick look at the command again, basically it's just a kube control apply, namespace ArgoCD, and then the manifest file for installing ArgoCD. So pretty simple there. If you want to verify your installation, you could do a kubectl, get all, and then specify the namespace of ArgoCD. And there you should see that your resources are starting to come up. So not everything is up right now. Some pods are still coming online, but these are all the different components that your ArgoCD installation is going to require. Now to access ArgoCD, we actually need to do a little bit of port forwarding to get to the ArgoCD web GUI. So to access the web GUI, we're going to be connecting to this service/ArgoCD-server listening on port 80 and port 443. So we're just going to do a kubectl, port forward, specify the service, namespace ArgoCD, and I'm going to port forward 8080 on that service. So that's port forwarding. I'm going to pull up a web browser here, and I'm going to bypass this certificate check. And now we get to the login. So the default username is admin, but you will have a different password than me. So in order to get the password for your ArgoCD installation, head on over back to the command line, and we're going to use a kubectl command to pull the secret. So the command is just a kubectl command to pull the ArgoCD initial admin secret and then base64 decode it. So that's my password. I'll just throw that into my clipboard and paste it in here, and I should be signed on. So let's go ahead and actually deploy our first application here, as that's the best way to get a good understanding of how ArgoCD works. So in my other tab, I have my GitHub repository. So in this repository, I have two applications, and it's actually the same application, it's just wrapped differently. So this is a simple Kubernetes web application. And the first one is deployed using Helm, and the second one is deployed using Kustomize. Now, Helm and Kustomize are pretty big components of deploying Kubernetes applications, so if you don't understand those, you should get familiar with them. I have other videos available to help you learn those. But if you aren't familiar with Helm or Kustomize at the moment, that's fine. You should still be able to follow along with this video and get a good idea. One of the cool things that I'm going to show you is actually some nuances between Helm and Kustomize deployments, which I think a lot of people don't understand why you'd use Kustomize over Helm, for example. But enough of that. Let's get back into ArgoCD. And I'm going to pull this into my clipboard, actually. And then I'm just going to go New Application. And then for the application name, this can be anything you want, but I'm just going to call it Helm-Web App. And then I usually like to specify my environment. So I'm going to say this is our dev environment. And then underneath here, project name, you can just select default. And then after that, we have a really important option, which is our sync policy. So you can see that there's two different options for our sync policy. There's manual and there's automatic. So this is a pretty simple concept to understand. Basically, if you select manual, ArgoCD will detect the changes in your GitHub repository, but it's not going to apply them to your Kubernetes cluster. So you'll actually need to go into ArgoCD and hit the sync button before the changes come over for your application. Now, if you choose automatic, you won't need to click that synchronize button, and ArgoCD will see the changes and then just pull them over. So commonly for companies just getting started with ArgoCD, they usually go with automatic for their dev environments and then manual for their production until they're more comfortable with ArgoCD deploying changes to production all the time. We're going to start with manual, as there's a couple of nuances I want you to see with ArgoCD. So we'll stick with that. And then we have our synchronization options, which we'll get a better understanding later when we actually start doing our synchronization. But one that I want you to enable right now is auto create namespace. And it does exactly what it says. It's going to automatically create the namespace in your Kubernetes cluster if it doesn't already exist. So let's scroll down. The next section is our source and our destination. So our source is our GitHub repository. This is where our application configuration lives. So I'm going to paste in my GitHub repository. Now, if you're following along with this tutorial, you probably want to fork my repository and put your repository in here so you can make changes to your repository and have your ArgoCD pull it. So I'm putting mine in here. And then underneath, we want to select the path. So this is just the path within the repository. We're doing our Helm application first. So we'll choose Helm Web App. And then for the destination, you can see that there's just one option here, which is our Minikube Kubernetes cluster. So ArgoCD can actually control the deployments to other Kubernetes clusters if you want to. And it's a pretty common scenario to have a single installation of ArgoCD controlling the deployments to multiple Kubernetes clusters. So if you had multiple Kubernetes clusters set up, you would just select which one you want to, and then you would select the namespace. So this was our development. So I'll just call it dev. And then underneath here, you can see that it's detected that this is a Helm deployment. So within my Helm deployment, I'll just go here. You can see that there's 3 different value files. I have like my values dev, values prod, values .yaml. This is the default values YAML file. I'm going to be using my values-dev, and it's going to pull up all the values within here. And for my specific application, it takes in this custom header and it outputs it to the user. So whatever's in here, it'll push out. So I'm going to go back here and I'm going to hit create, and our application should show up here. And it looks like ArgoCD picked it up right away, and it says it's out of sync. And the reason it's out of sync is because ArgoCD now knows about this application. It can see the GitHub repository, it can see the manifest files there, but it does not see this application within our Kubernetes cluster. And this is because we have set it to manual syncing. So in order to sync our application, we need to hit this sync button. And then we can just hit synchronize, and you can see that it's just going to run through and synchronize our application. And you can see right away it detected everything about our application. It knows that it has a configuration map. It knows that there's a service and a deployment and a replica set and 5 different pods. So let's go ahead and head into Kubernetes and just verify that our application actually deployed there. So we'll just do kubectl get all namespace dev, and you can see that all the pods are there, all 5 pods. Now, if you wanted to actually access the application, you could do that same port forwarding command, but we want to specify in this service. And then let's just map port 888 to port 80, which you can see the pod is listening on here, or the service is listening on port 80. And it did not find my application because I did not specify the namespace. So I'll specify the namespace of dev. And now it says it's port forwarding to it. And I'm getting an error here. It's actually not HTTPS. Just change that to HTTP, and there you go. You can see that our application is deployed, and that message is coming up here and saying this is on the dev environment. Okay, so that's how easy it is to deploy an application to ArgoCD. Let's go ahead and turn on auto synchronization and actually make a change to our application and just watch ArgoCD deploy to it. So I'm going to head on over to ArgoCD and just go to app details, and I am going to scroll down here, and underneath sync policy I'm just going to enable automatic syncing. Hit OK, and that should be it. And then within our application, under the values-dev, I'm going to change the replicas from 5 down to 2. So I will commit the changes, head on back to ArgoCD, hit this refresh button, and you can see how quickly it picked it up. Sometimes it takes about 30 seconds, but it picked it up, and you can see that the last sync result is okay, and it is pointing to this commit, which matches the head, so everything has been synced up properly. And you can see that all the old pods are dying. So instead of having 5 pods in our dev environment, we now have 2. And it's pretty crazy how quickly ArgoCD picked up that change and implemented it. All right, so the next thing I want to show you is how you can actually roll back using ArgoCD. So right now we're in a state where we made changes and now we have 2 replicas, but our original configuration had 5 replicas. So let's pretend that this was like a bad configuration change that we put in and it's affecting production, and we really need to revert back to our old configuration. Now, what you would do in that situation is you could either make the change in GitHub and just apply the fix in GitHub if you know what the fix is, and ArgoCD would automatically pick up those changes and sync your fix over to production. But if you don't know what the fix is and you just need to go back to a previous working version, what you want to do is a rollback. So what you would do is head on over to this History and Rollbacks button, and here is the complete deployment history for ArgoCD. Now, I have a couple of additional deployments to this application that I did while I wasn't recording, so I probably have a longer history than you have in yours, but just to demonstrate how easy it is to roll back using ArgoCD, you would just find the GitHub revision number that you want to roll back to, and then you would click here and hit rollback. And here we get a message saying that if you want to roll back, you need to turn off auto sync. And this makes sense because if you had auto sync turned on and you rolled back, it would just sync your application back to the most recent version on GitHub. So that's why you have to disable auto sync. So we're okay with that. We'll disable auto sync for our rollback to work. And you can see that it's progressing, going through here. And now we are back on 5 pods for our deployment, and it's saying out of sync because we are on an older version of our application. We're on the revision that had 5 replicas, but remember that GitHub is currently set to have only 2, right? So live on GitHub, we have replicas set to 2. So if we wanted to just go back to our current live version, we could either just manually sync again or just turn on automatic syncing. So we'll just go ahead and do that. So we went ahead and did that. And it looks like it's already going through and removing those old pods. So that's pretty simple for our Helm application. Let's go in and deploy our customized application. So I'm going to hit New App, and then I'm going to go Custom App. And let's do dev, choose default. I'm going to choose automatic here. And then the repository name, we're using the same repository. And then for the path, you can see with our customized application, we have a few different options here, and it's just the difference between Helm and Kustomize. With Kustomize, you use overlays. So I'm going to choose our dev overlay for our dev environment. And then I'm going to choose the Kubernetes cluster, namespace of dev, which I know already exists, but if it didn't, I could make sure that this is enabled to automatically create it. And then at the bottom here, you can see that it's detected that it's a customized application. And our options here is basically the name prefix, name suffix. This is just basically what it names some of the automatically generated resources, like configuration maps. We don't need to set that though, so we'll just hit create. And now our application is automatically being created. We don't have to hit sync because we set auto sync on. And if we head in there, you can see that it's already deployed 3 pods for our customized application. So if we head on over and do kgetall namespace dev, you can see we have 5 pods 2 of them are from the Helm app, 3 of them are from the customized application. Now I want to demonstrate why you would use a customized application over a Helm application. So I'm actually going to make 2 different changes here. I'm going to make one to my Helm environment and one to my customized environment. So I'm going to head on over here, and under Helm web app, let's change the custom header. And it's important that we're changing the custom header because this is a configuration map item. So I'm just going to change it to dev environment of my Helm app. And then hit commit. And then I am going to go over to our custom application, go to overlays, go to dev, and then I'm going to go to this config properties. And this is where the customize application is pulling the configuration properties. And I'm going to change this to welcome to the dev environment of the customized app. And we'll hit commit. And ArgoCD is going to detect the changes for both these applications, and it's going to update them both, but only one of them is going to actually represent the changes, and I'll show you why. So just to verify that everything is happening in ArgoCD, I'm going to go to ArgoCD, and I'm going to go to applications, and I'm just going to refresh the apps. Let's hit refresh. Oh, you need to select them. And there you go. You can see that the view has been refreshed. So what happened here is very important to understand. You can see that the custom app says it's healthy, but it's out of sync. And then the Helm app says it's healthy, but it's synced. And there's actually a very good reason for this. And it's actually a little bit difficult to explain. I'm going to explain it the best that I can. But basically, when it comes to Helm versus Kustomize, when you make a change in Helm, all it did was update this configuration map with the new values, but you can see that the pods never restarted. So the pods have not yet picked up the changes, whereas in our Kustomize application, you can see that there's 2 configuration maps. It has the old configuration map and the new configuration map. And all the pods are much newer. You can see that they're the same age as the new configuration map. Now, the reason why our Kustomize application says it's out of sync is because this old resource still exists. And according to ArgoCD, there's only one configuration map. This is old stuff that needs to go away. So in order to get rid of this old configuration map that is no longer required, let's head on over to sync and then hit prune and then synchronize. And this is going to get rid of all the resources that are no longer required. And there you can see that it just went and deleted that old resource that was no longer required. Now, if you want to enable this, so ArgoCD does it automatically on future updates, just go to app details and enable pruning of resources. And now, whenever the Kustomize application gets updated, the new configuration map will get created and the old one will get removed. Now let's go on and head on over to our Helm application. So back to our Helm application, go into it. Now, when we look at our Helm application, we can see that there's only one configuration map here. And if we go into it and have a look, you can see that it actually picked up our changes. However, our pods have not restarted since we've made that change, so they haven't picked up the change. So there's actually 2 ways that we could fix this. The first way, which is not the correct way, is you could just go here and actually on the deployment, and you could restart the pods. And it's basically going to create a new replication set, bring up 2 new pods, and they're going to pull over the new configuration map. And this will actually fix it. Hey guys, Future Brad here. Basically, the concept that I was trying to articulate is that Configmap should be treated as immutable objects, which means you shouldn't be updating them, but you should be creating a new version of them instead. Now, Kustomize takes care of this for you with the concept of Configmap generators, but when it comes to Helm, you need to take care of this yourself. So the correct way of updating our application in our Helm chart repository would have been to go into the values.yaml file and not only update the configuration value, but update the configuration map name as well. And then this would have created a new configuration map. And then we could have pruned the old configuration map just like we did with the Kustomize application. Okay, so now that you have a good understanding of how to use ArgoCD using the web GUI, I'm going to show you the ArgoCD CLI. So the easiest way to get started with the ArgoCD CLI is to do a brew install ArgoCD. Once you have ArgoCD installed, the next thing you need to do is use ArgoCD login to log into your ArgoCD server. So just make sure that you still have your kubectl Portforward to the ArgoCD service enabled, and then run the ArgoCD login command, and then just localhost 8080, and certificate warning, I'll just hit yes, and put in admin, and then I need to grab my password. So I'm going to paste it in here. Again, if you need your password, just run that earlier command I showed you on using kubectl to pull the ArgoCD initial admin password. So you can see that we are logged in. Now, if you want to see all the commands for ArgoCD, just hit ArgoCD and then scroll up, and then you can see all the different commands that you have. The one that you're going to be using the most is the ArgoCD app command. So I'm going to run ArgoCD app, and here you can see all the different ArgoCD app commands, and they're all pretty self-explanatory, but I'll go over the most important ones here. So let's go ahead and just start running them. So I'm just going to do a little bit of resizing so you guys can read this, but it's ArgoCD app list, and you need to spell ArgoCD correctly. So we'll do that. And here we go. We can see our two different applications, and it tells you everything you need to know about them. So the application name, which cluster it's on, the namespace. This is the project, so it's a good way to organize it. We just had default. And then like the synchronization status, the health, the sync policy. So all pretty good informational stuff here. Now, if we want to actually create an application using the ArgoCD CLI, you can grab the command that I'm about to put in from my GitHub repository, but it's just going to be the ArgoCD app create command. And I'll paste it in here and just go over it. So we're just creating the web app custom one. We're pointing to our repository. I'm specifying the path and then the destination cluster. And then for everything else, it's just going to pick up the default values. And you can see that it was created. Now, if we do the ArgoCD app list, the status is out of sync, the health is missing, and the sync policy is none. So basically, we didn't specify a sync policy, so it defaulted to no sync policy. So let's go ahead and sync this application. So we'll do the ArgoCD app sync and then specify the name. And you can see that it had some issues, and it actually tells you what the issue was right here. So it couldn't create it because the namespace prod is not found. So we didn't specify that parameter to automatically create the namespace. So let's just go ahead and create this namespace using kubectl, and then we'll try to sync again. So namespace prod is now created. Rerun our sync command. And there we go. It looks like everything is up and healthy. Let's do the ArgoCD app list. And you can see that our prod application is now synced. And if we do kubectl get all namespace prod, you can see that prod is up and running with 4 pods. Now let's go ahead and make a change to our application. I'm just going to go here and let's go to overlays, prod, replicas, and just change the replicas to, let's say, 6 replicas. Hit commit. And now we have 6 replicas in our configuration. But if we look here and do our ArgoCD app list, it actually hasn't detected the change yet. So let's do it again. And still not picking it up. Let's do it one more time because it does take up to 30 seconds. And there we go. Okay, so it's out of sync. Now, if we wanted to actually have a look at what these changes were before we synced it, we could do ArgoCD app diff and then put in the name. And it gives us a diff exactly what the change is. So we know that the change is replicas went from 4 to 6, so it's a pretty safe change. If you wanted to check this in the GUI, you would actually just go in and go into your application and then go to app diff and then compact view, and it would tell you the same through the web console as well. So pretty safe change. Let's go ahead and sync that using the CLI. So I'll just do ArgoCD app sync and sync it up. And kget all namespace prod. And you can see the new pods came online. Now, if you wanted to check the history of this deployment, you would just do ArgoCD app history and then throw in the name. And there you go. We have the 2. We have the original deployment and then the newest. Now, if we wanted to roll back, you would just do ArgoCD app rollback. And then you would specify the actual ID. So we're currently on ID 1. So if we wanted to roll back to the original, we would just say roll back to 0. And there you go. It should be back on 4 pods. If we do kubectl get pods namespace prod, you can see that we have 4 running pods and 2 terminating. So the CLI is pretty easy to use. Now I want to show just a few more commands before we get going here. So if you wanted to get information about the app, we would just do ArgoCD app get and specify the name. Tells us everything about it. If you wanted to get the actual logs, instead of get, you would put in the logs. And you can see that this shows you the logs for our application. So we have 4 pods and they haven't got any traffic yet. So it's basically just the startup message for 4 different pods. And if you wanted to actually change any parameters of ArgoCD using the CLI, you would use the ArgoCD app set command. And then it gives you a list of all the different configuration items that you may want to set. Now, the last thing I'll show with the ArgoCD CLI is I'll actually just delete our application. So I'll go ArgoCD app delete and then hit yes. And it does take a minute or 2 to actually sync this change and actually delete all the resources. But if we do it again, you can see that the application is now gone. Alright, so that's it for the lab tutorial on ArgoCD. I hope you enjoyed the lab. If you haven't already, check out my videos on Helm, which is going to teach you everything you need to know for getting started with Helm charts. And if you're interested in other DevOps related topics, go ahead and check out the other videos on my channel. Thanks again for watching, and I'll see you guys in the next one.